To understand how our planet reacts to increasing CO2 concentrations in the atmosphere, geologists look at past climate variations. In doing so, geologists can determine the sensitivity of the Earth's climate to CO2 change, which is vital in determining the magnitude of future warming. The boron isotopic composition of ancient foraminifera that lived in the ocean can offer clues. Foraminifera are tiny species made up of calcium carbonate shells. During their life, foraminifera incorporate small amounts of boron from seawater into the carbonate shells. When they die, they sink to the seafloor and are incorporated in the sediment layer. These shells represent a sort of time capsule of the environment at the time they were alive. So a marine sediment core lets us look into the past, back thousands or even millions of years ago. Studying the boron isotopic composition of those foraminifera can help us reconstruct ancient seawater pH, an indirect measure of atmospheric CO2. The more CO2 in the atmosphere, the more CO2 is absorbed in seawater, and the more acidic the water becomes. Boron has two isotopes, boron-10 and boron-11. The boron isotope composition of foraminifera is determined by the acidity of the surrounding water in which they were produced. Less boron-11 is built into the foraminifera shells when the water is getting acidic. However, foraminifera are tiny, typically 0.05 millimeters to 0.5 millimeters, and only contain around 0.1 nanograms of boron. Typically, analyses require 10 nanograms. So we need a lot of foraminifera in order to properly measure the boron isotope composition. Selection is time-consuming and done by hand-picking and microscope work. Isotope measurements are done by MC ICP MS. With the JET interface, the sensitivity of the instrument is significantly increased, producing higher signals of boron, while the 10 to the 13th ohm amplifier technology reduces the noise of the analysis. The combination of the two is very powerful because it increases the signal-to-noise, which has various positive effects. 1, it creates higher precision for the same sample size. 2, less material is required for the analysis, so less time is spent on selecting the foraminifera. And 3, you can look at other seafloor records that contain very low amounts of specific foraminifera species. Samples can be measured either in solution mode, after thorough chemical separation of the boron from the sample, or in situ, by laser ablation. The software integrates with third-party lasers through dedicated plugins, which removes the need for having two computers, one for the laser and one for the mass spec. Just when you thought it couldn't be done, the thermoscientific Neoma ICP MS raises the bar. The new Neoma Multicollector ICP MS, illuminating the edge of discovery. How will the Neoma Multicollector ICP MS transform your science? Visit thermofisher.com/Neoma and find out.